So I want to welcome everybody to the general session on the Argus 2 retinal prosthesis, Learning to See Again. If you are using an assisted listening device, please turn it to channel 1. Channel 1 for the assisted listening devices, please. This presentation will last approximately 60 minutes, and the remaining 15 minutes of the session will be reserved for questions from the audience. Please note that the session is being audio and video recorded, and don't forget, please silence your cell phones so that we don't have ringing during the middle. The speakers for this session are Dr. Jacque Duncan, Dr. Duane, I'm going to kill it, Geruschat, all right, Dr. James Handa, Kathy B., and Brian Mech. Dr. Duncan is professor of clinical ophthalmology, is the director of the Retinal Degeneration Clinic at the University of California, San Francisco. Dr. Geruschat is currently... I should have checked with you first. I apologize.
Call me Duane.
Duane, okay, got it. Duane is currently an associate professor at Salus University, who began his career as an orientation and mobility specialist, teaching students with multiple disabilities. He's the former director of research at the Maryland School for the Blind. Dr. Handa is a highly skilled surgeon and clinician and professor of ophthalmology at the Johns Hopkins University School of Medicine. And Kathy B. is an Argus 2 clinical trial patient. And Brian Mech is the vice president for business development for Second Sight Medical Products, the company behind the Argus 2 retinal prosthesis. With that, I will turn the microphone over to the speakers.
Thanks, Steve, and I want to thank the organizers of the Visions 2013 meeting and the Foundation for inviting us here today to present in this general session. It's really an honor for us to be both a sponsor of the meeting and to be able to be here and talk to all of you about what is the first ever approved therapy for severely affected retinitis pigmentosa patients in the United States. I believe we have a really exciting program. It's going to be packed with information today, and I'd like to welcome all of you and thank you for being here and attending. So I'm not going to speak very long. I'm just going to give you a little bit of backstory here, a little bit of history. The Argus 2 is a retinal prosthesis that has been over 20 years in the making. Back in the late 1980s and the early 90s at Duke University, and then right here in Baltimore at Johns Hopkins, some fundamental work was being conducted to see if you could use electrical stimulation of the retina to produce vision. That early team included surgeons, Drs. Eugene Dewan and Mark Humayan, and researchers Dr. Gilles Danieli and Dr. Robert Greenberg. You might know some of those folks. Their early work, which was actually funded in part by the Foundation, showed that in fact it was possible to stimulate the retina and produce vision. And in 1998, Second Sight, located just outside of Los Angeles, was formed to advance the technology further and develop a device that could be implanted for a long period of time in patients. Along the way, the company has benefited greatly from additional funding from the National Eye Institute, the Department of Energy, and the National Science Foundation to the tune of over $100 million. In addition, private investors have invested even more than that in the company. So all told, it took us as a company, Second Sight, 15 years and over $200 million to get where we are today. And that is to have a device that's approved for use in the United States that partially restores vision for people that are profoundly blind from retinitis pigmentosa. Dr. Duncan, who will speak after me, is going to give you a lot more detail about how a retinal prosthesis works. But at a very basic level, a prosthesis uses electrical stimulation to replace the function of the degenerated photoreceptors in the retina and trigger responses from the other neurons in the retina that still survive. It is similar conceptually to a cochlear implant, which restores hearing to the deaf, which you might be familiar with, but uses a camera instead of a microphone and stimulates the retina instead of the cochlea. In 2002, we began the very first ever long-term trial of an active retinal prosthesis. It was the Argus 1 and had just 16 electrodes. A half a dozen patients participated in this study in Los Angeles. We didn't expect that it would produce much in the way of useful vision, but it was intended to demonstrate proof of concept and answer two very basic questions. The first was, could a user make sense of this new visual input? And could you continue to stimulate the retina for a long period of time, periods of years, and could you do it safely? The answer to both of those questions was yes. In fact, some of the subjects that participated in that study could do amazing things with just 16 pixels of visual information. And some of you here today might recall meeting Linda at the Visions meeting in 2007 in Kansas City. She was an Argus 1 user. And here we are today, over 9 years later, and patients are still using the Argus 1 device. In 2007, we began the clinical trial of the Argus 2 retinal prosthesis. It was a second-generation implant. It was much smaller, had many more electrodes. It was a multi-center international study, the very first of its kind anywhere in the world. As of today, we have a participant in that study that has just passed her 6th year of use with the device. And in fact, she's here today, and you'll get to meet her very soon. She was the very first participant in the Argus 2 clinical trial. Dr. Duncan will also go over the results of this trial, but suffice it to say at this point that the results led to commercial approvals for the Argus 2 in the European Union, the Middle East, and now here FDA approval in the United States as of February. Our U.S. launch is set for later this summer in a dozen centers across the U.S. We announced the cities in which those centers are located yesterday. I won't go through them here, but if you're interested, I'd be happy to tell you later. And we'll be adding more over time. Another thing that we're spending a lot of time is actively pursuing insurance coverage and payment, and that keeps us very busy. We've had ongoing discussions and applications with Medicare that are we expect rulings on very soon. Thus, for us, this Visions meeting is very timely, and again, we thank the FFB for inviting us to present in this general session. We're delighted to be a sponsor of the meeting. Please feel free to stop by our booth tomorrow. It's booth number 1 if you haven't been there already, and we'd be happy to answer any other questions you might have. Tonight, though, we have a very exciting program with 4 speakers. The first is Dr. Jacque Duncan, who's already been introduced by Steve. She's going to explain how the system works and review the clinical trial data so that you would have a better understanding of what a potential RP candidate could expect to achieve with a device like the Argus 2. Then Dr. James Handa, based right here in Baltimore, will explain who is and who is not eligible and walk you through the first 2 stages of this therapy. There's 4 stages altogether. The first 2 are determining whether or not you're eligible. That's a clinical determination, and then the surgery. And following Dr. Handa will be Dr. Duane Geruschat, who's going to cover the last 2 stages of the therapy. And those are referred to as fitting, which is programming of your device, and then low vision rehabilitation. And finally, we'll have an Argus 2 clinical trial participant, Kathy, and she'll talk about her experience in the clinical trial and with the system. And like Steve said, we're going to save 15 minutes at least at the end to answer any questions that you might have. So without further ado, I will turn it over to Dr. Jacque Duncan.
Thank you, Brian. Well, it's really an honor to be here to tell you a little bit about how the Argus 2 system works. I had the privilege of being the clinical site director at UCSF during the Argus 2 clinical trial in the United States between the years of 2007 and the present. We still have participants coming in for follow-up. So the system works by using a special little video camera that is worn in a pair of glasses, which communicates wirelessly with a chip that sits on the retina. And we have a video that can explain in detail exactly how the system works, and we'd like to show you that video now.
In Second Sight's Argus 2 retinal prosthesis system, a miniature video camera in the eyeglasses captures the scene. The video is processed by a small portable unit and transformed into instructions which are sent back to the glasses. These instructions are then transmitted wirelessly to the implant on the eye. The implant consists of a receiver and an array of electrodes. Instructions are received and corresponding signals sent to the array, which emit small pulses of electricity. These pulses stimulate the retina's remaining cells and are transmitted down the optic nerve, conveying visual information to the brain, which perceives patterns of light. Patients learn to interpret these visual patterns.
Okay, I think that's a nice overview of exactly how the system works, again, with a special little video camera worn in a pair of glasses that communicates pictures of the world to a little device that sits on the surface of the retina to communicate information with the brain that the patient can interpret and understand. So the clinical trial of the Argus 2 device enrolled 30 patients in a total of 6 centers in the United States and 4 in Europe, involving 13 surgeons. Patients are now, as Brian mentioned, entering their 6th year of follow-up, and the device has been well tolerated, and there have been no significant safety concerns with the device to date. Their participants were about 70% male. 97% of them had retinitis pigmentosa, while 1 had choroideremia. And most of the participants had just barely the ability to detect any light. So these were patients with very advanced stages of vision loss due to retinitis pigmentosa. There were a few adverse events associated with the device, including low pressure after the surgery and some mild inflammation, all of which responded well to treatment, and none of which resulted in any permanent visual impairment. No one lost the amount of vision that they had at baseline upon receiving this device. So the safety profile was felt to be very successful. So how did patients benefit from this device? Well, the device has been helpful in helping patients to appreciate, improve visual function in patients who use the device. There were a number of measures of visual function, which Second Sight had to really invent, because once you get below the ability to see the big E on the eye chart, there are not good, careful ways to measure low levels of vision. So Second Sight, to their credit, worked very hard with low vision specialists to identify ways to determine whether the vision had improved. These included measures such as the ability to identify the location of a square on a computer screen, to determine the direction of motion of a target on a computer screen, and to measure visual acuity, not with letters initially, but to determine how well people could see based on the fineness of bars of light that were spaced out. The name of that test is grading visual acuity. And patients who received the device did much better with the device on all of these functional tests than with the device off. In addition, patients gained the ability to recognize letters, and we have a video that will show you that demonstrates patients being able to identify letters using their device. Because the closed caption staff would like me to first describe what you're going to see and then recapitulate it after the video, there's no real way to put the text of what the subjects are participating onto the video. So I'll explain in advance what you'll see, and then I'll summarize again afterwards for the benefit of those using the closed captioning. The video will show you a subject using the Argus 2 device who is looking at letters on a computer screen. Initially, the letters are very large, and the patient moves her head around such that she scans the device across the letter in order to understand what the letter says. During the video, the size of the letters decreases to the point that the letters are quite small and fit within the size of the device, so the patient can actually appreciate them pretty well without moving her head around. And now we'll show that video. So the patient is tracing the letter.
Yes.
She notices it's an R, correctly recognizing the letter. Traces,
Yes.
identifies the letter S.
Has this gone smaller?
Yes.
She can see the letters are smaller now
I don't know.
and
Yes.
identifies the O.
Okay.
Yes.
And as the letters get smaller, she continues to recognize them.
K.
Yes.
That was a K.
C.
Yes.
Now this letter fits within the array,
An O.
and she can recognize that that's a letter O. So you can appreciate from the video that we just showed that initially the patient was able to recognize very large letters that occupied the majority of the computer screen. But as the letters got smaller, she was equally able to recognize those letters correctly. In addition to being able to read letters, Second Sight went to a lot of trouble to determine how much benefit patients were getting from using the device in their lives. So they measured the ability of patients to walk using orientation and mobility tasks. This device is used in the context of the usual orientation and mobility tasks used by the patient. So patients who used cane travel continued to use their cane travel and were measured with the device on and with the device off. And the study showed that wearing the device with it on, patients had a much easier time correctly identifying the location of a door in a wall, following a white line on a floor, and performing tasks such as following the line on the floor is very analogous to you identifying the lines of a crosswalk when a patient is out in the street. They then went on to study different therapist-related tasks, and we'll show you some videos of patients using the device in everyday settings to show you how they benefited from the use of the device. Overall, 77% of patients reported a positive improvement in their ability to perform activities of daily living with the device on. So we'll show you a video now demonstrating some of those activities that patients found more easy when they were wearing the device. So this shows a gentleman identifying a spoon on a white countertop, a very low contrast spoon on a counter, and he can identify the location correctly with his device on. This will show a person watching another person walking down the street.
Je sais pas si c'est encore réalité là-bas.
Oui. And he can locate the person walking.
Ah ouais, après c'est par là.
And even though she's a little ways away from him, he can tell which way she's moving and where she is. Here, this patient will be determining the direction of movement of a target. Again, it's a person walking past. And he's able to say, yeah, the person went by from my right to my left. Here, this patient will be counting posts in the street in French. So he counts 1, 2, 3, 4. He can identify 4 posts in the street. This patient will be walking across the street using the device to identify the location of the curb. And as he's walking across, not using any orientation mobility aids, he approaches the edge of the curb, which is a little lighter in color than the street. And when he gets close to the edge, he pauses, identifies the difference. He says something about there. And he identifies the location of the curb and correctly steps up onto the curb without using any orientation mobility tools. Here, this patient is using a cane with his Argus 2 device. And this patient can see the line that he's walking along. And when someone walks in front of him, he stops. Without touching the patient with his cane, or the person walking by with his cane, he identifies that there's a person in the way and stops walking. Then continues on, integrating information from the cane with the line that he sees with the Argus 2 system, and then walking with the normal speed. And he can see he's walking along with the cane, and on the sidewalk, and stops. So these are some examples of how patients benefit from use of the Argus 2 device in activities that everyone encounters in their daily life. The device is not intended to replace or eliminate the patient's reliance upon orientation and mobility, but to improve your ability to get around using the orientation and mobility skills that you already know. It helps people better identify crosswalks, avoid obstacles, and to find doors and windows. It provides a better connection to the environment as well as other people, helping to know, people report that they are better able to identify when someone approaches them at their desk that is ready to speak with them. They can determine whether people are paying attention or if they've already walked away, providing patients who wear this device with greater independence. However, it does, as I mentioned before, does not eliminate the need for aids that you already use, such as a cane or a dog, and it does not provide the ability to perform tasks such as driving, reading small print, or recognizing small details such as facial recognition or facial details. So I hope that's given you some overview of how the device works and what patients who receive this device can expect in terms of improvement to their quality of life. And at this point, it is my privilege to introduce Dr. James Handa, Professor of Ophthalmology at the Johns Hopkins Eye Institute, Wilmer Eye Institute.
Well, that was really a wonderful overview by Jacque. It really, for me, it sort of solidified a lot of the experiences that I've been able to witness over the past several years that I've been involved in the project. As Brian had mentioned before, I'm the surgeon involved in it, so that's really my main task. And so in some ways, I'm really kind of the gatekeeper, and I'm the technician within this project. And what do I mean by that? Well, it's my role to explain to you some of the eligibility criteria that we look at, because there's a very careful selection process to make sure that people who are going to get the device are really going to benefit from that. And so there's some very simple, there's a sort of a production that we go through. The initial stages are a simple phone conversation to try to gauge a level of interest and to get some background information to make sure that we think it's feasible. The next stage is to have an eye exam so that we can verify the diagnosis of a retinal dystrophy. People have to be 25 years or older. People have to have really advanced stages of disease so that their light perception in the better seeing eye. The intention is that we're only going to place the device in one eye, so it's important that both eyes are severely affected. We also will look at to make sure there aren't any other contraindications that might predispose you to failure. These are ocular disease conditions that we think about from a surgical standpoint. We will do some ancillary testing, taking photographs of the eye, measurements of the eye to make sure the eye is not too large or too small for the device. If people have had cataract surgery in the past, that does not invalidate the ability to have it. In fact, it's something that we do during the surgery just to create some space if we need to during the procedure. At the end of that, we also give a video and some information for you to take home to very carefully evaluate to see what you're getting yourself into, because not only is there the surgery and the recovery and the training process, but we also have plans for the post-approval study. So we're hopeful that people who are going to have the surgery will be willing to participate so that we can learn more about the device. If that all seems proper and the patient is interested, then there's a second visit where we go through the consent and we give a little bit more background on what exactly is going to happen. And so the second phase that I've been charged to talk about is the actual surgery. And Jacque gave a very nice overview of sort of the nuts and bolts of how the device works. My role is to place it on the eye. The surgery, with all of the surgeons who originally participated in the trial, the average length of time was about 4 hours. So when you consider most retinal surgeries last a couple of hours, it's a bit more involved. but I'm going to reassure you that all of the steps that we go through are all things that we have done. It's just an orchestration of different movements put together in a more comprehensive fashion. The surgery is done either inpatient or outpatient. Whether one is admitted to the hospital is predicated on whether you have medical problems that we think would be better suited for someone being managed in the hospital, but we can certainly manage healthy people who are otherwise healthy on an outpatient basis. What we basically do is the device that actually accepts the video signal, we place that on the exterior part of the eye, and so I reflect back the two layers, or the two skin layers of the eye, I like to call it, place it right on the eye. It is secured with stitches, and there's a band that we place around, so it's almost like a belt that sits around the eye, and that's very secure. We will reflect the two skin layers of the eye back over that, so you actually don't see it, and it doesn't become exposed. Then there's a ribbon that connects that receptive device to the actual chip that will convert the signal to an electrical neurologic signal that the retina can understand. And that's the most delicate part, where we place the chip on the surface of the retina. I have to put it in the right location, and then it's secured in place by basically placing a tack through the retina and into the eye wall. It sounds terrible, but it's remarkable how stable the device has been through the years. And the mention of not any serious adverse outcomes from the surgery is one that is true. It's really remarkable how well tolerated the device is in the eye, and I think in part of it is because it was very carefully studied to choose biocompatible materials to enable these things to stay in an eye for a long period of time. So post-operatively, we have, as is typical for many operations, we will see the patients the next day, a week later, 2 weeks later, a month, 3 months, and then it goes every 6 months following that. And the purpose of those visits is so that we can make sure that your eye is healing appropriately so that the device will work. My role at this point, post-operatively, is, again, to make sure that the patient is doing well. If there are any potential problems from the device, or say you accidentally bump the eye, it's important for us to take a look to make sure that there's no damage to the device or the eye. Those sort of routine things. And the bulk of learning how to use the device and the training is upcoming. I'm going to pass the baton to Dr. Duane Geruschat. Thank you.
Thanks, Jim. Most of us are in academia, and it's a wonderfully intellectually stimulating bubble, but there's no mistake, it is a bubble, and it's always really great to come and deal with consumers, especially informed consumers, because it keeps our feet on the ground. Many of you have been to low vision clinics, and at some point in that low vision clinic, you probably met with a therapist who provided you with instruction with optical devices, non-optical devices, maybe came to your home and taught you how to do things in your home. I'm a low vision therapist. Many of you have been to blind rehab centers. I see a lot of canes around here, and a lot of you probably had orientation and mobility instruction. I'm an O&M specialist as well. So my role with Second Sight is in these areas of the therapies. I was involved in the clinical trial, helping them establish functional assessments. How do we evaluate the benefit, if there is any, of this technology? And now my role is helping them to develop curriculums and therapy sessions that can be provided once these implants occur in the hospitals. So Jim did a nice job with the first two phases of the program. I'm going to take on the last two phases, which are called the fitting and the low vision therapy. So once the surgeon has said you're cleared for fitting, the next week you will come in, and you will on average come in 2 to 3 weeks in a row. And at each one of those 2 to 3 week sessions, you will spend 2 to 3 hours in the hospital in this fitting procedure. We acknowledge that on occasion there have been a few patients who were special patients. They had some interesting things going on. So there's a possibility you might even have to come in for 1 or 2 additional sessions. During this fitting procedure, you will not be taking the device home. So there's a delay there of 2, 3, 4 weeks before you actually get to have any fun with the thing by playing around with it in your home setting. What happens in the fitting situation? You're sitting there. There's a little external unit that you have called a VPU. It's the control system of the technology. A computer is plugged into that control setting, and it measures the feedback or measures the electrical activity of the chip, which is in your eye. And there are a lot of electrodes in this little chip. Electrode is nothing more than a fancy word for a dot of light, and you experience these dots of light. And what they do over those 2 to 3 hours is they determine how much stimulation needs to be provided to that electrode so that it will fire so that you can see a light. They don't want to give it more energy than it needs, but they also don't want to give it too little energy so that it doesn't fire, it doesn't stimulate so you can see it. So you go through these protocols where each electrode is evaluated and monitored for its amount of stimulation it needs, and then you are considered fitted. Once that occurs, then you're ready for your rehab sessions. I'm going to give you a general overview of these rehab sessions, and the reason I say general is because we acknowledge that each hospital has the right to do their rehab sessions the way they want to do them. We certainly are going to make recommendations. I know that I'm going to be going to each hospital, working individually with the therapists initially to show them the things that we've learned and that we've developed because of our experiences, but we acknowledge that each hospital can do their own thing. But in general, what's going to happen is that if you've been through a low vision clinic, it's going to be similar to that in as much as we're going to teach you to use this piece of technology. It has a lot of neat things that it can do for you. In terms of the word neat, that means it can be complicated. So we need to show you how to use the control box. It has filters, which allows you to manipulate the image to enhance your ability to see it. We teach you how to use these filters. It's not that you could not learn these things on your own. In fact, I didn't get involved with this program until a number of years after it was already going. And I saw many of the patients, and many of them had on their own figured it out. So it's possible to do it by yourself. But we also know that we can make it easier for you by simply teaching it to you. And so our job is going to be to teach you these manipulations of these filters and just how to use the technology in the clinic. We've developed a kit of instructional materials that are used in the clinic, and we'll send you home with it. It's easier to have success if you have controlled environments with controlled things that you're looking at. So we're trying to help you learn to use it, get you feel good about the success with it, and then ultimately we will be in your homes with you, teaching you how to use it for the things that you want to do with it, including O&M. In conclusion, I want to give you just a couple of examples, and in the Q&A, if you want to hear more examples, I can give you some. Keeping in mind, and you're all informed consumers, so you know how each of you really is unique in terms of how you use your technologies for blindness or low vision, and so it's hard to make generalities, but there are a couple of big events that we see out there that I think represent the kinds of potential that it has. Jacque had mentioned crossing the street. I know that anybody in here is totally blind and uses a cane, crosses the street by themselves frequently. I guarantee you that you have a story about how one time you crossed the street that you know and you end up on the wrong corner, in the middle of the street or halfway down the block, climbing through the hedges. It's the price of doing business if you're totally blind and you're independent. If that street has crosswalk lines, I have seen many patients who are able to use their Argus technology to detect the crosswalk lines. And by detecting the crosswalk lines, you eliminate the problem of veering. For those of you who are totally blind and travel independently, you know how profound that can be as an experience for you. I have another patient who lives in her home with her husband and her daughter. She's a night owl. She's the last one to bed. For the last many years, because she's totally blind, her husband or her daughter would always walk through the house before they went to bed, make sure all the lights were out before they went to bed. Now she can tell you that she uses her Argus technology. One of the things is that they no longer are obliged to do that, and she feels really good about contributing to her family unit by being able to walk through the house with her Argus unit on, detect which lights are on, which lights are off, and to essentially turn all the lights off to prepare to go to bed. The last thing I'll say to you is something which we call quality of life. Not everyone ends up with some specific functional independence task that has high value to them. But I meet many, many patients who will say, I have sight again. And they do things like enjoying looking at a fireplace, being able to enjoy the flicker of their television. A gentleman reports on a dark night looking up and feeling the stimulation, detecting the moon. And this is a high value activity, so it doesn't necessarily increase your independence, but it does increase your own sense of quality of life and the value that you have to it. The last thing I'll say is that For those who've been through rehab, you know that this is true. The more you put into it, the more you get out of it. And so this is not the sort of thing where you get one of the physicians to drop this thing in your eye and we fit you, and then it's like magic, it just naturally happens. It does require motivation, it does require effort on your part, and you're going to maximize what you get out of it by working hard with this technology, just as with every other technologies that all of you folks are using. Thank you.
Thanks, Duane. Before we get to our last speaker, I wanted to say a few words. So I've been with Second Sight almost since it started. It started in 1998. I joined in March of 1999. And in that time, I have been very privileged to meet a lot of truly amazing people, very talented people, doctors, inventors, employees at our company, and patients, people with RP that aren't patients. A lot of people I really admire. But the group I would say I hold in the highest regard is the roughly 40 or so people around the world that elected to participate in one of the clinical trials that we sponsored. For these folks coming in, there was no data, there was no certainty, no basis to understand what to expect. We told them they shouldn't expect to get anything out of the device, and that they were certainly subjecting themselves to risk. Oh, and by the way, we're going to ask you to come in every week for 4 or 5 hours to do some testing. And yet they did it. They did it anyways. We could probably spend another entire session examining the motivation for such irrational behavior, but we don't really need to because they did it. And because they did it, we're here today. Not only did the participation of these 40 individuals make commercial approval possible, it made the product and the therapy better. The kinks, the problems, the knowledge that we gained along the way, they were largely worked out at the expense of these pioneers, so that you, as a potential patient, don't have to come every week for 4 or 5 hours of testing. Not only did these pioneers forge a road for others to follow, they paved it. They made it easier for everyone else by doing all of the research and development, the real heavy lifting. So our last speaker today is the very first participant in the Argus II clinical trial, which began just over 6 years ago. A pioneer of pioneers, if you will, and I'm sure you're going to enjoy hearing her story. And so I introduce to you Kathy.
How close do I have to be? Pull it down a little bit. Can everyone hear me? Oh, great. Well, hello, everyone. I am truly honored to be here and share my journey of this clinical trial with you. I've really enjoyed actually listening to the doctors up here, and some of them I just met for the first time. And now that it's been 6 years, the first 3 years of my journey was really working hard. So this brought back a lot of memories of some of those tasks. To go back to the very beginning, and why and how did I get to be part of this study? My mobility instructor had brought it to my attention that they were going to be doing a study with Argus II. He thought I would be a really good candidate. And if I really wanted more information, here's the number, and, call and get some more information. And I really started to think about, I think I really want to do this, because my motivation at the time was really forwarding research. This is a hereditary disease. I do have 3 children. I don't want to get emotional. I know. And I really wanted to do something for someday if I had grandkids. Well, now I have 4 granddaughters, but then I didn't have any. So for me, it was really about the work, and I really didn't expect to get, I didn't really have expectations of this. If I got some benefit out of it, great. And certainly I was hoping for that benefit. And I have had some benefit. But I really didn't expect anything. I thought of it really as a job. And truly it was a job because, well, before I even get into that, I'll talk about just getting the implant. That's the next step. Okay, yes, I told them I'm going to do this. And they said, okay, great. Physically, everything's great. Here is your consent form, take it home and look it over. Now, wouldn't you think a consent form would be like, a page that you have to sign? No, 20 pages. I feel this booklet and I'm thinking, wow, what have I got myself into? Okay, so we studied that, and it really was the time that you really had to put in. They had to tell you everything that might go wrong, but I really felt I'm really a physically fit person. I really shouldn't have a problem, and I haven't. But I did, for 3 years, see them once a week, the 3 hours in the research lab, plus an hour going each way, and really the first year even spending more hours than that. So that was one day, and any actual physical appointment, that was another day that you had to go in to have your eye exam every 2 weeks, and then once a month for so many months, and have the OCT scan and all the tests that you have to have done. So the fun part really was getting the device, and I did not get to take it home right away. But that first day that I did get to take it home was really fun. I could hardly wait to get out in the park across the street from me, just to go see and walk with my guide dog, which I have a guide dog, and just take a look and see what I could see, other than in the lab and looking at the computer screen. And I want to see the real life stuff. So I walk across the street and I walk in the park and I'm like, wow. Because I'm seeing flashes of, there's lots of contrast, trees, and all of a sudden I get this big flash as I step up on the sidewalk, and I'm thinking, what is that? I don't know what that is, so I had to go back, it was a big sign as you enter the park. I didn't even know that sign was there. I've lived there in the house for years, never knew the sign was there entering the park. And just walking and being able to see the contrast from the grass to the sidewalk and the trees, it was really fun actually being able to have it at home. And helping the scientists figure out some of the tests, I really felt good. I was really a big part of that, because I would be home doing something and came into the lab one day and said, guess what I did at home? I just sorted my laundry. And she's like, what? I said, I put the dark clothes in a pile, and the light clothes in a pile, and the white clothes in a pile. And I did it with she's like, really? So from me telling her that, they went out and bought socks. And they bought black socks and gray socks and white socks, 5 pairs of each, okay? So they put them all in and she wanted to see, okay, really, you did this? So she puts them all in a pile, and I go to pick them up one at a time and try and scan, and I go, oh. She's like, what? I go, well, you didn't get the exact same socks. She goes, yeah, they're all the same style. Well, the gray ones felt a little different than the black and the white. Now, after you've been totally blind for a long time, everything's about the feel. They had to go buy some different gray socks that felt just like the black and the white ones. And also the test that we did walking on the line in the room on a black carpet. And, they had a straight line or it curved. You had to follow the line. First day I walk on the carpet, I'm like, oh. They're like, what? I go, I can feel the tape. They took white tape to put, on the carpet. They're like, you can feel the tape? And Dr. Maya's like, do we have to put boots on you or something? So they figured out something else, some padded squares. There's no way you can feel the line. There's no way to cheat on that test. So every time they tried, I really felt like I helped them out with a lot of information, really working with them. Have thoroughly enjoyed having it. I can honestly say I don't use it a lot in my home. After being blind for such a long time, I really feel I'm pretty high skilled and really can do a lot of things in my home. Other little things like helping with the laundry, or I use my glasses more outside for mobility, fun things. Fun, even sitting in the car driving. I love to see movement of things, because watching that video with all of those people up there doing those tasks, I want you to keep in mind, they can see nothing without those glasses. We cannot see movement. We cannot make any, we don't see any shapes. So what they were doing strictly were with that Argus 2 device that they were able to do that. And it's really pretty amazing, and it really has been a lot of fun being able to use them. I really appreciate all the doctors that have really spent all this time and everyone raising money to further the research. It will not be as difficult for you with a device or having to spend as much time. Like they said, the initial getting the device might take a month or two. The surgery was, I was pleasantly surprised. I really was able to recover very quickly. I was an outpatient, came in the next day. Probably took about 6 to 8 weeks before I really didn't think about it. I really could never feel anything in my eye. I could never feel all that hardware. It was just recovering from all the little stitches that were in there. Once that was all healed up, I've never felt a thing since. I can't feel anything in my eye. And I've never really had infections or anything. I've been very fortunate. So it's really been quite a wonderful experience. And I'm very thankful that I had this experience. And I'd be happy to talk to any of you later through the rest of the conference. I kind of stayed low-key until after this talk. I didn't wear my device around this morning. I wanted you to listen to the doctors first. They could give you a lot of information. And but I'll be happy to talk to anyone later. Thank you so much.
Thank you, Kathy. That's truly amazing, and thank you for sharing your experience. It's just wonderful to hear all of your enthusiasm about it. With that, we'll take questions for those who have them. We have mic runners. Corey, we have a gentleman up here first. Well, we have to use the microphone.
I'm Kathy's husband, but so just as a clarification on your comment, you were not doing the driving, were you?
Okay. Gentleman right there.
Thanks. This is extremely interesting and inspiring. I have two questions. The first, just as a matter of curiosity, what's the size of the matrix you put in the retina in terms of the number of photoelectric cells?
So, this is on, right? So the array of electrodes has 60 electrodes on it. It covers roughly 5 millimeters by 4 millimeters, about 20 degrees of visual field. And in the US, however, we're only going to be using 55 of those 60 electrodes.
Why?
Why?
Yeah.
It's a long story, and it's not that interesting. So,
okay. All right, well, then let me ask you a second question. Maybe the answer to that one will be more interesting. Do you think you might work towards a binocular version to provide the added depth cues and so on one might get from that?
So I think, with cochlear implants, which have been around almost 25 years now, they started off with single-sided, and there are almost universally bilaterally implanted now. I think retinal prostheses will go the same way eventually, maybe 10 years from now, I don't know, but both eyes, then you can have better 3D vision, better depth perception and things like that. So I think we'll go there, but this is still early days.
Gentleman over here in the blue who just raised his hand, or the young lady who was with him.
Hello. You briefly mentioned that certain optic conditions and diseases would disqualify someone for this surgery. For example, I have controlled glaucoma. Would that disqualify me?
Jim?
I don't want to be the one to give bad news, but but yes, mainly it's so glaucoma, retinal, a chronically detached retinal retina, something like that.
I would think that controlled mild glaucoma without a whole lot of visual field loss might be compatible with receiving the device. Certainly, if there's damage to the optic nerve, the message cannot get from the retina to the brain, and that's why we're cautious before recommending that. And when we answer your question, we do have pause when we hear that people have glaucoma. But Brian, is there any thought that someone with controlled mild glaucoma could be a candidate or no?
So the way the device label works and it reads, and label is just a fancy term for the FDA approved language about who is eligible and who is not, is that you cannot have a condition that would prevent the device from working. So I think that's open to clinical interpretation, and someone can interpret it the way Jackie did, which is if the glaucoma is controlled and there's evidence that the optic nerve is intact and capable of transmitting a signal to the visual cortex, that patient might be eligible. Another clinician might see it differently.
No, I actually agree with that, and here's where the surgeon's input can be valuable. So with mild forms of glaucoma, glaucoma is similar to retinitis pigmentosa, where the vision loss early is in the peripheral vision. And since my task is to put the device right in smack dab in the center spot, the macula, we can put it in an area where we would expect there to be functional optic nerves. So I think, as in most things, we start out very, very conservatively in what we decide to who's a candidate, and I think as time goes on, those indications might relax a little bit.
Corey, there's a question over here first. Gentleman over here in the corner to the right. And then Judy, there's a gentleman in the back in the green with glasses. Put your hand up again, sir, so they can find you. And then we'll come back to you. Yes, sir.
I've seen a video of the surgery of this. It was very impressive. Of course, I'm not a doctor, so anything impresses me. But is there a special training or special techniques that a doctor, a retinal surgeon, would have to learn to do this, or is this all pretty standard procedure? And second question, I think kind of related to that, if it has to be upgraded or could be upgraded someday, can it be upgraded, say to 120 electrodes?
Do you want me to take that? Sure. So, you know, in terms of, again, the way I look at the surgery, anybody, a vitreoretinal surgeon who's had training should have the skill set to perform each and every task of it. But it is longer surgery. It requires attention to detail, measurement, specific. I think just paying attention to detail is what really is the difference between an operation that goes smoothly and the one that perhaps might not go quite as smoothly. Second Sight has actually, for the first couple, will always have someone in the operating room with you to sort of proctor you through, to sort of give you the subtle clues that enables you to put the device in a little bit easier. From the aspect of being able to sort of take out and update anything in the system, I think it's theoretically possible. But I think from a technical surgical standpoint, it certainly could be done. From I'm not a bioengineer, and I think the ability to take out the chip and attach it to the ribbon with all the electrodes might be a a challenge to hook that back up.
I think, just to add to that, I think what we would do is we would take out the entire device and put in an entirely new one.
Gentleman in the back.
Yes, I'm on your list for your procedure, and I'm in the New York area, and you mentioned before that you announced that there are locations that have been chosen.
Yep.
Do you know which place in the New York area?
Yeah, unfortunately, as of today, we don't have a center in New York City, which is pretty amazing. But we hope to have one soon. So right now, I guess the closest one to you from New York would be the one in Philadelphia at Will's Eye.
Also, one other thing. I know there's software involved in this. Am I correct?
Yes.
Isn't there a possibility that software upgrades might happen?
Absolutely. In fact, our near-term product development is really focused on upgrading that visual processing unit, which if you swing by the booth, we can put it in your hands, you can feel it. It's about the size of a deck of cards. And there's resident firmware and software on there that can be changed and upgraded very easily without touching the implant. So we did that throughout the clinical trial. We implemented features like contrast enhancement, edge detection, image inversion, so going from black on white to white on black. And now we're exploring much more advanced image processing techniques that could result in color vision, higher resolution vision, face detection and recognition, things like that.
Thank you.
Yeah. Corey, straight in front of you.
Yes.
Yeah.
Okay, Joe, I do have advanced RP, so I think maybe I'm in that realm of where you would be. I guess my main question is the fact that these have been trials all the way up to this point, and now that you can purchase them commercially. I guess one I'd have for, is it Linda? I'm sorry. Kathy, I apologize. I think, I use a cane and light perception. I do pick up on the fact that if you're picking up light and flashes and contrast, that would be, very exciting and, obviously sight, restored sight. Can you speak to the financial piece at all, any of you? For instance, if you have insurance, how that's going to work out. You mentioned Medicare earlier, but if you have federal policy for health insurance, is that something that any of you can speak to yet?
Yeah, so I'll do my best here. This is very new ground.
Right.
One of the problems with developing new therapies for previously unmet clinical problems is there's nothing that's come ahead of you to pave the road in terms of insurance. So in today's environment, we have no official coverage policy issued by any insurer, whether it's Medicare or a private insurer. Now, having said that, we have two applications before Medicare right now, one on the inpatient side and one on the outpatient side, for them to both cover and pay for the device. And we're cautiously optimistic that we will be successful there, but we won't know for sure. We'll know on the inpatient side towards the end of July, early August, and the outpatient side will be probably a little bit after that. In the meantime, we can, if a patient sees a doctor and the doctor decides that the patient is qualified and eligible and wants to do it, they can make an appeal on a case-by-case basis to that person's insurance company. And whether or not that's successful will depend on a number of factors. It's very hard to predict. The device itself is very expensive, and so it's beyond the reach of most people without insurance covering it, because the device plus the surgery plus all of the rehab and the fitting and stuff, by the time you add that all up, it's probably close to $200,000. And if Medicare covers it, then particular Medicare beneficiaries' copay would be limited to the maximum yearly payment, which is right around $1,000 or $1,100. That would be your out-of-pocket expense if Medicare covers.
Okay, we have in the back, and Corey, the lady here in the red jacket. But let's go to the back first.
Yes, thanks. Excellent presentation today. There were reports starting last summer about advances in the understanding of the actual code that the eye uses to send the signal back to the brain, and how it might improve the type of technology like you have. I wonder if you could give us some perspectives on how you see the advances in that knowledge maybe applying to the Argus or to similar technology.
I think what you're referring to is Dr. Nurnberg's work that was discussed last year. I think, to be frank, that the size of our electrodes, which is 200 microns in diameter, is such that we do not have the ability to specify which neurons we're going to activate and which ones we are not going to activate. And that is so much the fundamental part of retinal encoding. So I don't believe that any retinal prosthesis currently in the design phase would be capable of actually taking advantage of that understanding of retinal encoding.
All right, right here. And then Judy, if you can grab the microphone. There's a question up here, please.
You mentioned a few times of the importance of training, and I was wondering, is part of this training in pattern recognition? What is the form of the training that one gets to understand the input?
Yeah, they titled this Learning to See Again. Because of the progression of your RP, you all have visual memories, including being totally blind. You have a visual memory. So if I say banana, you immediately picture this yellow thing that has a certain shape to it. And you have visual memories of all sorts of things in life. The vision that's provided by Argus is not like that native vision that you had. It is they're calling it prosthetic vision, and so it is a different type of vision. It is light patterns, it's flashes of light. And your job is to learn how to interpret those patterns and those flashes of light. And part of the work that we would do in the therapies is, for now at least, I'm calling it, we're helping you develop a new visual memory bank. Because they are different images. They're not like an image that you ever saw before, and they're not like an image that I've ever seen before. I can watch the image on the computer screen, but I'm not exactly sure how even you're experiencing it. So a lot of the therapy is, if you know anything about how we as humans develop our visual system, if you look at 1, 2, 3-year-olds, they're touching things, they're looking at things. We're going into the store, don't touch anything. What does that little child do? They touch because they want to learn to interpret. You go to Nordstrom's while you're here in Baltimore to go shopping. You're going to go clothing shopping. What do? You walk up and you look at a blouse, you look at a suit, you put your hands on it, you touch it. You're connecting what you see with what you feel, and you're developing and refining your own visual memory. And I see that what we do with our full vision is exactly what we are currently proposing to do with the prosthetic vision, is the development of this new visual memory bank.
Okay, we have a question up here. And then...
Okay. Can patients with Usher syndrome type 1 qualify to get this implant? And the second part of my question is, would someone with who was deafblind be able to qualify, whether they had that type of Usher syndrome or not? And the type, you were talking about the type of things that you would see. Is there a possibility of color vision? Would it be black and white vision? Can you say more about that?
The patient, just briefly, so I'll just start. Usher type 1, just for people in the room who don't know, is the kind that is accompanied by very severe congenital hearing loss and retinal degeneration that begins in sort of the teenage years and progresses. So patients with Usher syndrome type 1 were not included in the Argus 2 trial. And so think that they probably could potentially benefit, but honestly, I don't think anyone knows because they haven't actually been studied in this context. Brian, do you have any thoughts?
Yeah, a couple thoughts. So, Jesse, there were 2 Usher's patients in this study? There was 1. And do we know what type 2? Okay, so I think a couple of things that are worth noting is If you're profoundly deaf and use a cochlear implant, then you are not eligible to get an Argus 2. Argus 2 is contraindicated, which means you cannot be used in anyone that has a metal implant in their head. So that's number one. Number two, with respect to profound deafness, is if you don't have a cochlear implant, I think it makes the rehabilitation process and the fitting process more challenging. I would never say impossible, especially after what we heard at lunch today, but definitely challenging. With respect to the question about color vision, the answer is yes. We have demonstrated that we can reliably reproduce colors in the clinical trial, in several of the clinical trial patients, which means that in theory, we can produce color vision simply by upgrading the visual processing unit that I talked about. It's actually not that easy though. It turns out that every patient has a different way that they need to be stimulated to see blue or pink or red. And therefore, you begin to quickly realize how much of a challenge that is from a fitting perspective, and it would take a very long time. So until we're able to streamline that process, I don't think it'll be a reality, but we've demonstrated that it's certainly possible.
Okay.
Can I just add a comment? Brian kind of alluded to the rehab part of it. I guess my comment, I don't know, be somewhat brash here, is that if these surgeons here say that you pass the evaluation making you eligible and they implant it, I'll teach you to use it. Rehab folks are used to doing that sort of stuff, so that's not a too high a threshold for us.
There's a lady in back in the blue, Judy, right over here. No, right here.
Can you address research on retinal implants that are directly stimulated by light rather than going through the video camera and the wireless connection and that sort of thing?
Sure. So typically, there's a class of retinal implants. Ours is called an epiretinal prosthesis because the array goes on top of the retina. There's another class called subretinal prostheses, where they put a chip of photodiodes underneath the retina. And so the photodiodes are activated by light directly coming through the lens of the eye, and they fire based on that light. So as you pointed out, you don't need a camera, which is potentially an advantage. So, and also the other advantage of that is that the chip moves with the eye, so you don't need to scan your head to change what you're looking at, you just need to move your eye. So that's also an advantage. You don't have to wear this external equipment. There are some disadvantages of that approach as well. One is that it requires that your path, there be an optically clear path to that chip. So if you had corneal opacity or perhaps vitreal opacity or something like that, the chip wouldn't work because no light would be getting to it. And of course you lose the advantage of having some of this external equipment of being able to upgrade. You can't, there's no image processing that you can do. Whatever that chip decides to do is what it's going to do. And you can't upgrade based on what you learn over time. So there's definitely pluses and minuses to both approaches.
From a surgical standpoint, it's more challenging. Technically, we certainly can do it, but it's going to have a higher complication profile postoperatively.
So I get the feeling that that's in the distant future, if at all.
There's at least, well, there's one active commercial effort in subretinal implants based in Germany. And in terms of how long it might be before, they're in clinical trials, and they're proposing to start another clinical trial. I don't know when that's going to start. It would only be speculation to guess when it would be approved, but certainly it would be approved in Europe long before it'll be approved here in the U.S. As far as I'm aware, and I think Dr. Fetterman is talking tomorrow, they haven't even started the clinical trial in the U.S. yet, so maybe he'll update us on the status of that.
I had the chance to work with 8 patients who had the subretinal implant actually at Johns Hopkins over the course of 15 months. We were part of a clinical trial that was run with company that no longer exists. And what I can tell you from the rehab side is that all the things that Brian said were true, that the nice thing is that it's in your eye, there's no external equipment, so there's nothing for you to learn, there's nothing for me to teach. The disadvantage is you can't manipulate that image. But an advantage that he didn't mention is that many of the patients in that clinical trial had a lot of vision. A number of them were still driving. They weren't necessarily driving legally from a visual field point of view, but they were driving from their point of view safely. They restricted it to 5 minutes to the grocery store, that sort of stuff. I'm not defending it, I'm just simply describing what they did. Many of them didn't use canes. And what they were experiencing, what I observed, was kind of an enhancement or an anticipation of the visual field. The classic example was a gentleman who had a young son, and the son would always leave the kitchen door half ajar, and he'd kick it with his knee. And they had a Cocker Spaniel, and he would often step on the dog because the dog would sit in various places in the home. And his wife noticed that with his subretinal chip implant, that he wasn't complaining at his son as much anymore. He wasn't stepping on the dog. In other words, he got a little bit of an enhancement of his visual field that gave him a little bit of preview of things that were happening in his environment.
Just as another point, there are over 20 different projects throughout the world on retinal prostheses. In many different countries using many different technologies. Certainly Second Sight has been a pioneer that these others are following on. How long it's going to take to get to either clinical development or actual commercialization is going to depend on the research results and how they find they work. But certainly Second Sight has led the way. Any other questions? Oh, all the way in the back. Judy, far back corner. Sorry, there's a bright light coming right at me from over you. So, whoa.
One other thing about the subretinal implant trials is they are relatively recent, like Stu was alluding. So I think the track record of safety is much, much stronger so far, at least for the Second Sight device. 6 years with the current device, as well as much longer with the earlier device, makes us, pretty confident that this device is well tolerated and safe, which is something that the other implants will have to take their time and demonstrate as well.
That is correct. Okay, in the back.
Thanks. This is for Kathy, if that's okay. Kathy, I was told that while you were addressing us, you were actually wearing the device.
Yes.
Are you able to describe for us what you can see?
At the moment, I have it turned off.
Well, darn it, turn it on.
The reason why I did that purposely, because I really had to kind of concentrate on what I was saying. And if I have it turned on, there's a lot going on. And I'm kind of looking like, ooh, what's that? What's that? And sometimes I can determine what things are by just the location of tables or chairs or people. I'm sure I'd be getting flashes all through here because there's so many contrasts. So I did have it purposely turned off.
Have you had it on since you've been in the hotel so far, wandering around?
I kept it off this morning all day until I came in here so that I didn't have to answer too many questions before the doctors actually spoke to really give you all the details about it. So now you will see me with it on, and feel free to stop and
I'm sorry, you did say that. I
Yes.
apologize.
And-
I'm sorry. One last thing is then, does it make a difference when you're around your home or in the park across the street, whether you're using it in daylight or nighttime? Does that have any effect on the function?
Daylight is better. The more light, the better. They did upgrade with some filters that do make it possible to pick up light even in the evening. For instance, year one, I could hardly wait till Christmas time thinking I'm going to be able to see all the little lights on the Christmas tree in our home, and I wasn't able to do that. Year two, when they had put the filters on to kind of enhance that, I was able to pick all that up. I could see all the twinkling lights on the tree and pick up, contrasting lights for outside, the moon. I was the one that came to them and said, hey, I went out and saw a full moon last night. They're like, what? Well, my husband said, hey, there is a full moon, go get your glasses. let's see if you can see this. And I was able to just kind of scan up in the sky and just point it out. I could not see the full circle all in one big, at one time, but I could definitely see the flash and kind of scan around the edges and actually point out where it was. And the fireworks too. 4th of July is coming up. It never used to be my favorite time of year because I could never see them, but now I can. I can't see the color. I'm one that I really don't see any color, but I can definitely pick up all the flashes in the sky. I can't be too awfully far away, maybe a quarter of a mile away, maybe, would you say? Maybe, within a quarter of a mile. I'm able to pick them up, and I try to, go somewhere where I know I can actually have a good vision of them.
Okay, with
Thank you,
that,
Kathy.
I want to thank everybody. I want to thank Drs. Duncan, Geruschat, Handa, Brian, Mech, and most definitely Kathy for sharing your experience with us. Thank you. Thank you for attending this session. Next, you'll be making your way to the welcome reception beginning in the exhibit hall. Keynote speaker Michael Higson will be signing copies of his best-selling book, Underdog. Hard copies and audio books are available for purchase. In your conference bag, you will find an exhibit hall raffle card. By collecting a sticker from at least 10 exhibitors, you can enter to win a prize by turning in your raffle card at the registration desk by 5 p.m. on Saturday. Winners will be announced at the awards dinner tomorrow night. After the welcome reception tonight, the meet and mingle networking sessions will begin at 8 p.m. Check your program for topics and locations. There will also be an impromptu gathering beforehand of parents of affected children who would like to connect. If you're interested in this, please meet at the registration desk at 7:30 p.m. tonight, and thank you very much.